Good afternoon, welcome. Bonjour à tous. My name is Mithura Sanmugalingam. I'm a Skills Development Officer at Teaching and Learning Services. And today I'm so excited to be here to kick off the highly anticipated 3MT or 3-minute thesis competition, also known as Ma thèse en 180 secondes here at McGill. This event holds a special place in my heart, as not only do I get to work with really cool people to make this event happen, but it showcases the incredible talent and dedication of graduate students in condensing their research, their entire research, into 3 minutes or less. This year marks my third time organizing this competition, and each year I'm more and more amazed by our graduate students' passion for their research and their ability to communicate and connect with you all, with the community, through sharing their research in such compelling and engaging ways as you'll see today. You're definitely in for a treat. We had over 150 students registered for the competition, and after weeks of training and practice sessions and the semifinals, or the heats as we like to call it, we have 15 finalists here today. Their journey has been one of growth, resilience, and hard work, hours and hours of hard work. So today we're here to celebrate their achievements. Thank you all for joining us today. Those of you here in person at the Faculty Club, we have a wonderful turnout. And those of you tuning in the live stream, thank you for being here and supporting graduate student research. I'd now like to take a moment to acknowledge the land that we're on. While some of us are physically here at the Faculty Club, many of us are tuning in from different places across the world. So today we'd like to take a moment to acknowledge some of the qualities of the physical space that we're on which McGill is located. L'Université McGill est située sur un emplacement qui a longtemps servi de lieu de rencontre et d'échange entre les peuples autochtones, y compris les nations Haudenosaunee et Anishinaabe. McGill honors, recognizes, and respects the nations removed from, as well as those still connected to the lands, as they are the traditional owners of the lands and waters on which we meet today. And so, as we're joined here today to celebrate the wonderful work and research that's being done at McGill, we want to recognize the lands and waters on which much of this work is being done, including my own. I also want to take a moment to appreciate the work that led up to this very moment. A large team is behind making this possible. The planning started way back in fall, and one of the beautiful things is that we have graduate students working behind the scenes, not just presenting today. So firstly, I want to thank our wonderful graduate student assistants who assisted with the training, the event planning, especially our student leads, Jessica Traynor and Pascal Ibrahim. To our amazing communications team, Connor, Sanhita, Safira, and Samuel. A thank you to our audio and videography teams, so Stu and Jonathan, thank you for being here with us each year. A shout out to our photographer today, Genevieve. A special thanks to Andrew, Jason, Alex Gavrilla, Alex Leapins, MJ, Hannah, Yiwei, and all other McGill staffs for their contributions leading up to this event. So with this, I am very excited to be introducing our co-host for today, so it won't be me. So please welcome Jessica Traynor, a master's student in educational leadership. She was also the 3MT student lead this year, and her thesis research focuses on exploring strategies that can help increase engagement across high school instrumental music education. Along with her, please welcome Isabel Sadowski, a doctoral candidate in counseling psychology. Her research explores the feasibility, acceptability, effectiveness of nature meditation programs using virtual reality for older adults to better support their mental health. Jess and Isabel have been working with us as student assistants for a while now, and they're wonderful co-hosts as you'll see today, so please join me in welcoming them on stage.
Hi, thank you very much. Welcome.
So thanks so much, Mithura. We're so happy to be here today. Today is really a culmination of the whole efforts of our whole team, but most importantly, we really want to highlight the work of our brilliant 15 finalists here today who'll be presenting their research in English or in French in 3 minutes or less. So as you can see, the order of proceedings is rather straightforward. On va commencer avec un aperçu du concours, ce que les participants ont tous vécu au cours du semestre écoulé pour arriver ici à la finale. So basically, we're going to go over a recap of the competition, the rules, the judging criteria, and then, to the most exciting part, the presentations. Après tous les 15 présentations par nos finalistes, le jury délibérera pour choisir les gagnants ou gagnantes. Et pendant ce temps, on vous encourage à voter pour votre présentation préférée pour le prix du public. So, while the judges are deliberating, after all the presentations, you, the public, get to vote for the People's Choice Award. There will be a link projected as a QR code on a slide behind our heads, or if you're tuning in, I should say, on the live stream, you can find the link in the description of the YouTube video. So either way, you'll have a way to vote for the People's Choice Awards. So we do have a few notes for our in-person audience. S'il vous plaît, assurez-vous que vos téléphones sont en mode silencieux. On ne veut vraiment pas interrompre ou déranger nos participants. So our participants are nervous enough as is. We really don't want to be adding to that. Mais quand même, vous pouvez prendre des photos. Mais s'il vous plaît, n'utilisez pas de flash ni de son. So, après tout ça, on vous invite en fait à une réception après qu'on annonce les gagnants du concours. So we invite you to please join us for a reception in the lobby after we announce the competition winners. So, what is the 3MT? It is a research competition that was developed by the University of Queensland in Australia in 2008. And, as you might have guessed, it is now an international competition. Le MT180 s'inspire du 3MT et c'était développé en fait par l'Association francophone pour le savoir en 2012 ou l'ACFAS, qui était vraiment, ils avaient le but de faire étendre ce projet à tous les pays francophones. So basically, graduate students will have 3 minutes to present their research in addition to a single static slide. So it's an oral presentation of their thesis. They're really going to try to present the implications to a non-specialist audience. They don't get to have any props or notes, no music, no costumes. While that could be fun, it's not this type of competition. Donc, ils devraient présenter d'une voix claire et ne peuvent pas chanter leur discours. So we have a team member who will be monitoring the time, and judges will be informed if any of our participants go over the 3-minute mark, as that is the main rule of this competition. So le chronomètre va démarrer dès que le participant dit le premier mot. So as soon as the participant starts speaking, the timer will start. And as you may be able to see behind me, the winners will be selected on the 3 following criteria. We really love groups of 3s in this competition. So the Canadian English criteria and the French ACFAS criteria are quite similar. Our first criterion is communication or talent d'orateur et implication. Donc, on veut voir leur passion pour leurs études et aussi leur qualité oratoire. So we're looking at the speaker pace, the terminology, their body language. We also want to understand them and see if that's easy to understand what they're saying, as well as the quality of the slide itself. Our second criteria is comprehension or structuration de l'exposé. So here we want to see that the participant is clearly explaining their research, the results that they found or anticipate finding, as well as the implications of their research. On va aussi voir l'équilibre entre les différentes parties de leur discours, donc l'introduction, le développement, puis la conclusion, et aussi si ça s'était fait d'une façon satisfaisante. And finally, we're looking at engagement or vulgarisation. Alors, est-ce que les participants ont utilisé un langage accessible? So we're wanting to see if they're conveying enthusiasm and they're holding our attention throughout. And also, are they making us want to know more? An important final thing to note is that in this competition, our judges are going to be evaluating our participants on the quality of the delivery of their presentation and not on the research itself. And so with that, I will pass it on to Jess to talk a little bit about the trajectory of our competition so far.
Wonderful. Thank you so much, Isabel. So, as you may be able to see behind you, it's been quite a road to the competition. Our presenters here have all been involved since January, some even registering as early as December. So, long road to get where we are today. And for starters, we had 170 students who answered the call for submissions and registered to participate in the competition. So, we went from 170 to 15, which is a huge deal. You should be very proud of that. And the story goes, after 2 rounds of presentation, skills training, and coaching sessions, they then advanced to the heats. Et après la demi-finale, les 15 finalistes que vous voyez aujourd'hui ont été sélectionnés. Les finalistes ont eu l'occasion de participer à une séance d'entraînement supplémentaire pour affiner davantage les techniques de présentation avant la finale. Et tout cela pour vous dire que nos finalistes ont travaillé très fort pour se rendre ici aujourd'hui. And before we see the students, I'd like to introduce our judging panel today as well as our prizes. Avant de commencer, j'aimerais vous présenter les membres de votre jury multidisciplinaire. So, over here right in front of me, actually, you can see we have our 5 judges who come from a variety of rich educational backgrounds. So I'll introduce them one-on-one. So for starters, in the corner here, we have Dr. Laura Weiner, who's the chair of our judging panel. So Laura Weiner, PhD Educational Technology, is the Director of Teaching and Learning Services and an Associate Professor in the Department of Education and Counseling Psychology here at McGill. Prior to that, she worked as a special advisor to the provost and is the senior educational technologist in the office of the CIO. She has taught in the faculties of education at McGill University, Université de Montréal, Concordia University, conducted research on educational and training applications of information and communications technology, most recently in the field of medical education, and published and presented nationally and internationally on faculty development issues, evaluation of teaching, learning space design, and ethical considerations in data use. So please join me in welcoming Dr. Weiner. Wonderful. Thank you so much for being here. Next, we have Dr. Liette Lapointe. Professor Liette Lapointe is a full professor at the Desautels Faculty of Management here at McGill. After being Associate Dean of Undergraduate Programs, she then took upon the role of Vice Dean Programs. As such, she had responsibility of all of the undergraduate and graduate academic programs and oversaw the Career Center as well as the Teaching and Learning Associates and the Wellness Advisor. Dr. Lapointe currently holds the Bromfin Chair in Information Technology Management, and she was awarded an honorary doctorate from Université Aix-Marseille for her research and involvement in her field. Her research integrates healthcare, information systems management, and behavioral issues. And her work has led to close to 50 papers and peer-reviewed publications, about 100 presentations locally or in national and refereed competitions, and more than 40 invited guest presentations locally and internationally. That's a lot. She has developed collaborations with highly recognized researchers at the local, national, and international levels. Her interdisciplinary research has included graduate and student training and is supported by grants from diverse councils such as the FRQSC, CIHR, and SHRC. She extends her research to impact practice and brings her expertise through public policy research and board membership. Please join me in welcoming Dr. Lapointe. All right, our next judge I'm happy to introduce is Dr. Joe Schwartz. Joe Schwartz is director of McGill University's Office for Science and Society, which has the mission of separating sense from nonsense. He is the recipient of numerous awards for teaching chemistry and for interpreting science for the public. Dr. Joe has hosted a radio show on science for 43 years, has appeared hundreds of times on television, writes a regular newspaper column, I know, it's very impressive, and is the author of 19 bestsellers. He has been awarded honorary degrees by Athabasca University, Cape Breton University, the University of Windsor, and Simon Fraser University. Also, Professor Schwartz is an amateur magician and often spices up his presentations with a little magic. Please join me in welcoming Dr. Schwartz. Awesome, thank you so much. Okay, our next judge to introduce is Justine Perez-Smith. Justine Smith is the screen editor at Cult MTL and film programmer. She's contributed to publications such as the National Post, the Globe and Mail, and Hyperallergic, writing about art, film, and culture. Since 2018, she has been a member of the Fantasia International Programming Team and curates the Underground Film section. Please join me in welcoming Justine Smith. All right, and last but certainly not least, we have a final judge who is new to the panel this year. We're so happy to welcome Atia Min. She's a PhD candidate and a 2022 Vanier Scholar at the Department of Human Genetics here at McGill. And she was the winner at the 3-minute thesis competition here at McGill in 2022, and then further triumphed as the first prize winner and People's Choice winner at the Canadian Eastern Regional Competition. Subsequently, Atia proudly represented McGill again at the Canadian National Showcase, organized by the Canadian Association of Graduate Studies, and again received the People's Choice Award. And then it extended globally even further and represented Canada at the North American 3MT Showcase, organized by the Council of Graduate Schools, CGS, in 2022. And again, she emerged as the People's Choice winner, which is a huge feat. It's remarkable, and it makes her the first McGillian to achieve such distinction in this competition, which is amazing. In 2023, she then represented Canada again by sharing her talk at an international graduate studies conference hosted by Qatar University, where she stood out among the 10 students, the graduate students selected worldwide. She also served as a distinguished speaker at the Thesis and Dissertation Talks, or TAD Talks, in 2023, eloquently representing graduate studies in North America. And I think we should highlight here that this experience has brought a lot of opportunities for Atia and really stands as a great example of where 3MT can take you locally and internationally. So we're very happy to have her here today. Please join me in welcoming Atia Min. All right, thanks again so much for our judges. Now we're going to move on and talk a bit about the prizes. And part of the reason why our participants may be here today, although of course they're all winners, there are some opportunities here. So as you can see, we've got 4 prizes today. Le jury décernera les premières, deuxième et troisième places. First prize in English and first prize in French are each $750. The English winner will advance to the Canadian Eastern Regionals, et la personne qui reçoit le premier prix en français avancera à la finale nationale de concours MT180 de ACFIS. The judges will name a second and third place winner among all of the participants, English and French, and the People's Choice Award will be awarded to the audience's chosen favorite, irrespective of the judges' selection. This is where you all get to vote, but we will get to that later. Le prix du public sera présenté aux candidats choisis par le public sans tenir compte de la sélection de jury. C'est ici que vous, le public, allez voter. On vous donnera des détails plus tard. All right, thanks for listening. I'll pass it back to Isabel to introduce our presentations.
Great. So now the moment we've all been waiting for, the presentations. So as mentioned, we have a total of 15 presenters today. And so we're going to be introducing each presenter. They're going to come up onto the stage, and then they will begin speaking, and the timer will start. So we want to wish good luck to all of our participants today. Bonne chance à tous et à toutes.
All right, and with that great energy in the room, we will get started. So it is my pleasure to introduce our first speaker, Michael Elegan. He is a fourth-year PhD candidate in quantitative psychology. And Michael's talk today is entitled Statistical Detection of Random Responding in Online Surveys.
On a scale of 1 being very inaccurate to 5 being very accurate, I want you to rate these 3 statements. 1, I am the life of the party. 2, I like to get acquainted with important people. 3, I don't like to draw attention to myself. Go ahead, rate them. Ready? All right. Rating scales like this one are used in research to measure various psychological constructs. For instance, items 1 and 3 just answered measure introversion, extroversion. Item 2 measures narcissism. All answers are final, no takebacks. In a real study, questionnaires are typically longer, some even 100 items long. Participants are recruited online, paid per questionnaire. With such incentives, what happens? Some participants might just click through an entire questionnaire randomly, and some might even resort to a web browser plugin that, with one click of a button, randomly fills in every field in the form. If you knew who these were, you would want to delete them from your data, right? If you knew who they were, well, you're in luck. My research as a quantitative psychologist developed statistical algorithms that detect random responders in rating scale data. How would such an algorithm work? The key is redundancy. Redundancy between item prompts. To illustrate, let's go back to the ones you just answered. If you agreed to item 1, then you're more likely to disagree with item 3. The two items tend to be correlated precisely because they measure the same trait, but only if you're answering non-randomly. A random responder can't help but deviate from this redundant pattern. So accumulating these deviations over a long sequence of items allows us to statistically separate random from non-random responders. My latest algorithm statistically guarantees catching 95% of random responders. It gets the job done asking only for two things: the response data itself and the scale per item. Is it a scale of 1 to 5, 1 to how many? That's it. That's it. Believe it or not, this algorithm does not require prior knowledge or data about how the items are related, and it does not require advanced statistical training to use. I just explained to you how it works. On account of its ease of use and statistical guarantees, I look forward to this algorithm becoming a staple in my field towards safeguarding the quality of data that down the line might inform how students are instructed, how patients are treated, how resources are allocated. So let me finish with an appeal. The next time you find yourself as a participant in a study presented with the awesome privilege of answering a 100-item questionnaire, then please, for the love of science, please answer attentively. And if you don't, I'll know. Thank you.
Awesome. Thank you so much, Michael. That was really enjoyable. And now, you as the audience can get used to the fact we're going to do a bit of vamping while we give the judges a moment or two to deliberate. Yes, you get to hear from us more. Great. Yeah, I really enjoyed Michael's talk. I cannot imagine, I know there's a lot of researchers in here, how irritating it is to work on a study for so long and then realize that not all of the data is like authentic and people haven't taken the time to actually reflect on what they're answering. So I really feel like that's important work, and I know you have a background in psychology, so I'm sure you can agree, Isabel.
Yeah, we really don't like bots in questionnaire research, so it's great that somebody is trying to get rid of those. So really, really appreciate that, and I'm sure there will be a lot of need for this moving forward as well.
Absolutely. So something else we get to do while we're up here is share a bit of fun facts about the presenters, getting to know them a bit more behind the researchers that you're seeing in front of you. So for Michael, I have that something he's interested in is he enjoys fencing, which is really cool, and also enjoys watching other people play video games, which I think is something a lot of people find. I find it so satisfying. I totally get that too.
Yeah, thank you so much, Michael. And on to our next participant.
Wonderful. Okay. So please allow me to introduce our next presenter. Dominique Lumley is a first-year master's student in the integrated program of neuroscience. Dominique's talk today is entitled Unraveling the Enduring Effects of Child Abuse on Perineuronal Nets.
Have you ever heard the brain be referred to as plastic? It sounds a bit odd, I know, but the expression refers to how malleable our brains are, or rather, how quickly they can reorganize themselves to help us learn. This is especially true for children, whose brains have yet to finish developing, hence why they're so quick to pick up new skills. Their heightened plasticity allows them to absorb information like a sponge. My research revolves around one of the many structures responsible for regulating this plasticity, known as perineuronal nets, or PNNs for short. These mesh-like PNNs surround neurons in the brain and protect them from degradation. But this protection comes at a cost. As the PNN sets in, it restricts neuronal development. The net is wound so tightly that the neuron no longer has space to grow and branch out. Thus, the more developed the PNN is, the less plastic the neuron becomes. In a healthy brain, these structures only set in towards the end of adolescence, when the brain is fully matured, meaning restricted neuronal development no longer poses a problem. Research from my lab, however, has found that in victims of severe child abuse, this development is altered, causing PNNs to mature faster and in greater number. These findings imply that victims of child abuse may be experiencing stunted brain development and reduced plasticity from an earlier age, hindering their capacity to learn, problem solve, and adapt. My research aim is to understand how these changes come about, By extracting these nets from the tissue, using a special technique known as laser capture microdissection, and taking a look at the genes expressed by the neurons encapsulated within them. You see, our development is not only determined by the DNA we inherit from our parents. Our environment has a say in things too. If we can imagine each of our genes as a light bulb, our environment has the capacity to switch them on or off. A healthy, supportive environment has the potential to light up the path to a bright future by switching on all the right genes. A neglectful or abusive environment, on the other hand, can leave you stranded in the dark. In taking a look at which genes are being expressed by these PNN-encapsulated neurons in both victims of child abuse and healthy controls, I hope to uncover whether or not there are any differences in which genes are being switched on or off between the two groups, and whether or not these differences can help us understand the changes in PNN development that we have observed. If I am successful in achieving this aim, not only will I further our understanding of PNNs in general, but my work will bring us one crucial step closer to understanding the lasting changes induced by child abuse, and, more importantly, how to reverse them. Thank you.
Wow, thank you so much, Dominique. That was amazing. And I, kind of a joke here, as a non-STEM person, I'm a music educator. It always amazes me when I'm able to so clearly understand a topic that I never thought I would. And it really seems like you're doing incredibly important work in learning about supporting people and also reversing damages from child abuse. So thank you so much. Speaking of Dominique, some additional information we have to share about her today is, I'm sure it's evident from that presentation, you can see how passionate she was, but she's always enjoyed writing and learning about the wonders of the human body, most notably the brain, and it's actually been a passion of hers since childhood, which is so great that she's always kind of had that interest. And one day she does hope to marry her love of writing with her passion for science and pursue a career in science communication. And
seems like she's off to a great start.
That's exactly what you're doing, communicating your science. It's perfect.
Great.
Amazing.
So with that, this brings us to our third finalist today, Alexandra Goudreau, who is a second-year PhD student in experimental medicine. Her talk today is entitled Nature versus Nurture: What Drives Tumor Behavior?
Every 14 seconds, someone is diagnosed with breast cancer. Despite amazing progress in developing treatments, hundreds of thousands of people are still dying every year. Traditionally, research is focused on the nature of cancer to understand its behavior. This approach has allowed us to pinpoint 3 proteins that exist on the surface of some cancer cells, which help them grow and multiply. By targeting these proteins, precision therapies can control or even cure the disease. I study a form of breast cancer that doesn't have any of these proteins. Because of that, it's called triple-negative breast cancer. It's capable of spreading to virtually any other organ, and for these patients, chemotherapy is the main treatment, but it isn't a cure. When TNBC cells eventually develop resistance to chemotherapy, and our precision therapies are no good, we're out of options. So when there's nothing in the nature of cancer for us to target, what do we do? Well, when it comes to human behavior, we know that nature is far from the only consideration. In fact, the debate of nature versus nurture goes back thousands of years. What makes us who we are? Is it the genes we're born with? Or is it the environment we grew up in? Today we know it's both. Yes, nature is very important, but so is nurture. So if we want to look at how a tumor is nurtured, we have to look at its home. We call this the tumor microenvironment, and it's a complex community with neighbors like blood vessels and nerves and non-cancerous cells, all living with the cancer cells and held together by connective tissue. My hypothesis is that there's something in that community that's nurturing the cancer. And so far, my results seem to say that this might be the case. By looking at TNBC samples underneath a microscope, I found that patients who have a lot of those non-cancerous cells and connective tissue do much worse than patients that don't. But when I only looked at the connective tissue, I didn't see a relationship. This says that there might be something in those non-cancerous cells that's nurturing the tumor. To figure out what that something might be, My next step is to use a new technology called digital spatial profiling. Compared to traditional methods that give the average expression levels for a random piece of the tumor, digital spatial profiling plots these molecules and their amounts within specific neighborhoods of that community. With this information, I can look for patterns between different molecules in the different regions and patient outcomes. And these molecules that form a connecting link might be something we can target with new precision therapies. In the 3 minutes that we spent together, 13 more people have been diagnosed with breast cancer. It's my hope that through this research, they and the millions of others like them will all have access to effective and targeted precision therapies. Thank you.
Thank you so much, Alexandra. That was really, really great.
Such an interesting talk, and one of the few times you can actually think about nurturing tumors, which is not typically something we want to do.
Yeah.
So apparently, Alexandra is an obsessive reader and has enough on her to-be-read list to last her for a lifetime, which I think with a lot of us in this audience is something we can probably relate to. But also just want to say that we're so appreciative of these really, really interesting talks here today. Never a dull moment.
I know, I feel like I'm going to be an expert in 15 different subjects by the time I leave here today. 15 more degrees for me. Just kidding.
You're working on it.
Yeah, I'm working on it. Perfect.
Great.
All right.
Alors ensuite, on a Manon Fantino, qui est en 2e année de doctorat en nutrition humaine. Et aujourd'hui, elle présentera « Je vois donc je mange » Instagram.
Nous avons tous été tentés, au moins une fois dans notre vie, par ce paquet de chips dans un de nos placards ou par cette deuxième portion de gâteau après un repas. Mais vous êtes-vous déjà demandé si nous avions réellement le contrôle sur ce que nous mangeons et comment nous mangeons? Ces questions sont au cœur de mon doctorat, qui vise à mieux comprendre les facteurs qui influencent nos comportements alimentaires. Notre génétique agit comme un manuel d'instruction pour notre corps. Il n'est donc pas surprenant qu'il joue un rôle important dans nos préférences et nos comportements alimentaires. Cependant, ce n'est qu'une partie de l'équation. Nous savons que l'environnement dans lequel nous nous trouvons peut également impacter nos choix. Par exemple, les médias sociaux peuvent exercer une pression significative sur nous, en promouvant des régimes à la mode ou en nous exposant constamment à de la nourriture. Ce qui peut avoir un impact sur nos comportements alimentaires de façon subtile mais puissante. Mon objectif est d'étudier ces facteurs de manière approfondie, afin de mieux comprendre comment ils interagissent entre eux. Et pour les étudier, nous avons mis en place une étude expérimentale, qui sera menée sur plus d'une centaine d'adultes et qu'on pourrait diviser en 2 parties. Dans la première partie, nous nous intéresserons aux habitudes alimentaires des participants, en utilisant des questionnaires adaptés. Nous regarderons également leur profil génétique, afin de voir si la présence de petites mutations peut rendre certaines personnes plus à risque de développer des comportements problématiques pour la santé. La deuxième étape, qui est sûrement la partie la plus palpitante du projet, consiste à regarder en temps réel comment le cerveau des participants réagit quand ils sont en train de regarder du contenu sur les médias sociaux et plus particulièrement sur Instagram. Les participants porteront un casque cérébral et seront exposés à des images reliées à une alimentation saine, malsaine ou des paysages. Cela nous permettra de voir s'il y a une différence dans l'activité cérébrale en fonction du type de contenu qu'ils sont en train de regarder. Notre cerveau, et plus particulièrement la partie frontale, joue un rôle clé dans l'autocontrôle, ce qui veut dire qu'une activité plus faible de cette région peut nous conduire à des comportements alimentaires impulsifs. Ma recherche a donc le potentiel d'identifier les éléments de notre environnement qui, en fonction de notre génétique, nous pousseraient à manger en trop grande quantité ou de manière impulsive. Ces résultats contribueront également à améliorer les traitements nutritionnels et surtout à personnaliser beaucoup plus les recommandations que nous donnons aux patients. Alors, si la prochaine fois vous reprochez d'avoir cédé à ce paquet de chips ou d'avoir tout simplement trop mangé, rappelez-vous que votre alimentation ne dépend pas uniquement de votre volonté et que non seulement vos gènes, mais également l'environnement dans lequel vous vous trouvez peuvent avoir un impact sur votre comportement. Je vous remercie.
truly fascinating work. Thank you so much, Manon.
Yeah, thank you so much. Always interesting to see how the accessibility of food content on Instagram can really impact what we're eating. I mean, not necessarily surprised if you're looking at burgers all day long that you might eventually want to eat a burger, but it's still really, really interesting work, and we're really appreciative of it. Also, something very impressive about Manon is that in parallel to doctoral studies, she actually works as a dietitian in private practice. So very, very cool. Amazing that she can manage both of those things at once.
Yeah, even looking over some of the bios we'll be reading later, it's so impressive at looking at you all as accomplished researchers and then human beings outside what you're doing, right? Like, no, but I'm serious. The idea of being this remarkable in so many facets is something that you all should really appreciate about yourselves, right? Well-rounded individuals here at McGill.
Much better than bots completing questionnaires.
Absolutely. Most things are better than bots completing questionnaires.
Great. So with that, on to our next finalist.
Wonderful. Okay, I'm pleased to introduce our fifth presenter of the day, Shamika Shenoy, who's a first-year PhD student in human genetics. Shamika's talk today is entitled, Decoding Immunity for Future Vaccines.
We have all weathered the storm of the pandemic. And kudos if you have got the vaccination badge of honor. But hey, have you ever wondered why these vaccines don't work the same for everyone? Well, as we all know, our immune system is a vigilant army that protects us against invading pathogens. And a vaccine is like a practice session for our immune system, which triggers antibody production, the soldiers of this army. However, every individual's immune response varies due to age, health status, and genetics. And this variation could greatly impact vaccines' effectiveness. So, how can we improve vaccines' efficacy? The answer lies within the genetic makeup of B cells, the specialized cells that produce antibodies. B cells perform a remarkable process called antibody class switching, where they cut and recombine DNA segments to produce specialized antibodies. But with all the cutting and the pasting, there's a potential for genetic oopsies. This is where the DNA repair genes enter the scene. They ensure that the whole process is error-free and right segments come together seamlessly. But the identities of these DNA repair genes remain a puzzle. And to solve this puzzle, I'm using a powerful gene editing tool called CRISPR. What's cool about this technology is that it uses specific enzyme to modify DNA at targeted sites and alter its gene function. Here's the interesting part. If I use CRISPR to turn off a gene responsible for fixing the DNA, and if that messes up the antibody production, I will know that that gene is important for our immune response. Crazy, right? Through this approach, I aim to create a detailed map of the DNA repair genes involved in antibody class switching. And this is going to provide deep insights into the molecular processes of our immune system. This knowledge holds tremendous potential. It can pave the way for precision vaccines tailored to our immune system. With this map of DNA repair genes, we are not just decoding immunity, but laying the foundation for a future where vaccines are effective for everyone. Thank you.
Well, that was wonderful. Thank you so much, Shamika. I feel like I really feed off of your brightness and energy, and that's encouraged me to try to use oopsies more in my vocabulary. I can't get it out of my head. The way she said it is so good. Something else that I just have to mention, because on the 3MT team, we help build these slides, is I just love the detail on this slide, how the second DNA has little boxing gloves on, and it cracks me up the more that I look at it. It's just so detail-oriented. So that's wonderful. Something to share about Shamika as well is that she's just so incredibly dedicated to her work and has had a passion for genetic coding for a really long time. So has integrated that seamlessly into her work now, which we're so happy to see today.
A real Sherlock of DNA.
A real Sherlock of DNA. That's a good one.
Yeah, I'm here all day with more one-liners, guys,
Yeah.
so get used to it.
Stay tuned for more jokes after this.
Yeah. But yeah, so I mean, we're also really curious when we see all the slides. There's a lot of work that goes into making these images, and you might not necessarily think about it when you're listening to these really engaging talks, but there's a lot of thought and a lot of time into really making this a precise and effective image. So kudos once again to our finalists for all of their great work.
Yeah, absolutely. Just continuing to have our minds blown sitting here. And we will continue on now to our next presentation. So it's my pleasure to introduce Michael Luo, who's a fourth-year PhD student in the integrated program in neuroscience. Michael's talk today is entitled Targeting Glioblastoma at its Root.
A man walks into a flower shop and buys a beautiful bouquet of flowers. Is it for a celebration? No, it wasn't. It was for a grave. Each year, thousands of Canadians pass away from brain cancer. My Uncle Hector was one of them. He woke up one morning with a terrible headache that wouldn't go away. So he went to the hospital where he was diagnosed with an aggressive type of brain cancer called glioblastoma. Despite the best available treatments, he didn't get better. And unfortunately, he passed away less than 2 months later. I study glioblastoma because I want to understand, why is it so deadly? And why don't our current treatments work? There are many types of cells in a tumor, and we're not targeting the right ones. The ones we need to target are called cancer stem cells, and you can think of them like seeds. Because just like a seed can grow into a weed, a cancer stem cell could grow into brain cancer. And unless you can eliminate these cancer stem cells, you can never truly cure the cancer because it will grow back. The problem with current treatments is they have a ton of side effects, but they are not able to eliminate these cancer stem cells. We need an alternative. Hector and my family have always been fond of gardening, and we want to remove a weed. You tear it up by its roots. What if we could do the same with cancer? Because just like a seed needs the right soil with the right nutrients to grow, a cancer stem cell needs support from surrounding cells in order to survive. My job is to figure out what these lifelines are, figure out how to cut them off. By looking at the genes that are turned on in the cancer, as well as all the surrounding cells, we discovered that the cells that the body's immune system are actually helping the cancer instead of trying to fight it. These immune cells in blue are sending chemical signals to cancer stem cells in red, telling them to grow and to multiply. So our next step is to grow these cancer stem cells in the lab, then treat them with drugs that block these chemical signals to either kill the cancer stem cells or at least stop them from growing. And we're very excited about this new treatment approach because we're actually targeting glioblastoma at its very roots, at the cancer stem cells. And we hope that this will increase the effectiveness of treatments as well as to minimize the side effects. And by doing this, we hope to change the narrative for the thousands of Canadians with glioblastoma to improve treatments. So rather than laying flowers on a grave, we can have more celebrations with our loved ones. Thank you.
Wonderful. Wow. Thank you so much, Michael. Again, another presentation that, looking at the title, I never thought I would be able to understand, but was able to follow so seamlessly. No, in all honesty. And the slide really helps with the understanding of the weeds seedling and that comparison. So I really want to thank Michael for that. Now, my fun facts about Michael, I actually got to talk to him about this at our lunch earlier, just because I found it so fascinating. He has a couple really diverse and well-rounded interests, speaking of well-rounded people. So some things he likes to do are archery, finding the latest slow cooker recipe, But then the biggest one is running marathons, which I don't think I could ever do. So it's, again, just really cool to see what people are up to and interested in, right?
Jess is doing a lot of learning today.
Too much, I'm tired. I'm kidding. The right amount.
Yeah, exactly. And we can see just the power of analogies to really explain difficult scientific concepts. So thank you for your wonderful speech making and communication, something that I'm trying to work on myself these days.
Well, this is good practice.
Definitely.
Active learning. Perfect.
And yeah, so we're just eagerly waiting to see the rest of the competition today, but it's been so interesting so far.
I know, and we're already 6 presenters down, so think about how quickly that time went. I feel like we just got here, so.
Exactly. And I'm almost at a spot where I'm going to start randomly pulling volunteers from the crowd, so watch out.
Yeah, get ready. Perfect. Well, it looks like we are ready to move on to our next presenter.
Perfect. Alors, ensuite, on a Corentin Conon qui est en 2e année de doctorat en génie électrique et informatique. Aujourd'hui, il présentera « Chanter à tue-tête en se garant » avec un avion.
Personnellement, je pense que j'aurais du mal à continuer de chanter, tant qu'on s'entend suffisamment sur ma vitesse. Imaginez maintenant qu'en plus de tout ça, vous ayez 500 personnes. Et que vous soyez en fait aux commandes d'un avion de ligne. Merci. Si vous et moi, So is that good like that? Okay,
Yes,
perfect.
Take a moment to breathe and then.
Okay, all right. Imaginez que vous soyez en train de conduire votre voiture tout en chantant à tue-tête votre chanson préférée. Imaginez maintenant qu'en plus de chanter, vous deviez passer la prochaine intersection dans très exactement 1 minute et 29 secondes à une vitesse de 38,74 km/h. Personnellement, je pense que j'aurais du mal à continuer de chanter tout en me concentrant suffisamment sur ma vitesse et sur le temps qui me reste. Imaginez maintenant qu'en plus de tout ça, vous ayez 500 personnes sur la banquette arrière et que vous soyez en fait aux commandes d'un avion de ligne. Bientôt, les pilotes vont devoir respecter ce genre de contraintes temporelles lorsqu'ils roulent à la surface de l'aéroport pour pouvoir permettre d'en optimiser la capacité. Et si vous et moi, on imagine déjà avoir du mal à conduire, chanter et respecter des contraintes temporelles, imaginez ce que ça veut dire pour des pilotes qui conduisent un véhicule un petit peu plus compliqué à manœuvrer et qui, au lieu de chanter, doivent répondre aux contrôleurs aériens à la radio, vérifier leurs commandes de vol et réaliser tout un tas de checklists. Ma thèse s'intéresse à la façon dont on peut rendre ceci possible d'un point de vue humain. Comment peut-on faire en sorte de permettre aux pilotes de respecter ces contraintes temporelles sans sacrifier d'autres tâches importantes pour la sécurité? Et dans ce genre de situation, les chercheurs du domaine commencent souvent par faire une analyse de tâches. Mais dans ce cas précis, comme les opérations sont complètement nouvelles, on ne peut pas se baser sur l'expérience des pilotes pour comprendre le problème. J'ai donc mis au point une nouvelle méthode d'analyse de tâches qui contourne le problème en se basant sur l'immersion des pilotes dans des scénarios réalistes. Et cette nouvelle méthode m'a permis d'identifier de nouvelles tâches dont le support est la clé pour le respect des contraintes temporelles. Et mes recherches s'intéressent maintenant à la façon dont on peut supporter ces nouvelles tâches. Et ce support peut être réalisé de 2 manières différentes. On peut ajouter un outil dans le cockpit pour guider les pilotes vers le respect des contraintes temporelles, ou on peut déléguer certaines tâches du contrôle de l'avion à des systèmes automatisés. Et mon objectif est maintenant de prototyper ces 2 solutions pour permettre d'en comparer l'impact dans un simulateur de vol sur la charge de travail des pilotes, leur conscience de la situation et le bon respect des contraintes temporelles. Et ceci devrait nous aider à déterminer la meilleure solution pour permettre au pilote de passer cette prochaine intersection dans exactement 1 minute 29 à une vitesse de 38,74 km/h. Et mes résultats pourraient également inspirer le domaine des voitures autonomes pour vous permettre de continuer à chanter en toute sécurité. Merci.
Thank you so much. We just have to say that that was handled so professionally. Like, I think he deserves another round of applause because that. We were like, take a beat. He didn't need it. He was ready to go. I really am amazed. Like, I have goosebumps. That was awesome. Thank you so much, Corentin.
Very, very impressive. And as you might maybe be able to guess by his incredible composure, Corentin is actually also taking his pilot's license right now. So probably good that he's so good under pressure.
And very on brand as well.
Definitely. Something also kind of funny about that is that it's talking about how people can now sing while they're parking their planes, but I don't think anybody should really hear me singing while I'm parking, so maybe we don't need this technology for me.
No, maybe we do. I want to hear that.
No thanks. But anyways, very interesting talk. Thank you so much, Corentin.
And we are ready to continue as well.
Perfect. So, up next, we have Yugu, who is a fourth-year PhD student in biochemistry. Yu's talk today is entitled From Snooze to Buzz, Identifying Drivers of Cancer Relapse.
There's a reason why it's called fighting cancer. From your initial diagnosis to all the daunting chemo sessions until finally you ring that victory bell that marks the end of your treatments. But that's not where the fight ends. Half of all cancer patients will eventually hear the words, "It's back. The cancer is back." That is 9 million people around the world who will relapse. Lurking in the shadows behind that victory bell is a silent enemy called cancer dormancy, where cancer cells take a little nap. These dormant cancer cells can completely ignore and sleep through the first round of treatments. Eventually, they wake up, grow aggressively, stop responding to the drugs, causing deadly recurrence. My PhD project aims to find the alarm clock that wakes up recurrent tumors and to find a therapeutic snooze button in them. To do so, I analyzed over 250 cancer patient samples of their primary and recurrent tumors. I found that cancer cells don't wake up alone. Instead, recurrent tumors harbor different immune cells, blood vessels, and a bunch of proteins. One of these proteins, called osteopontin, is abnormally high in recurrent tumors. Now, just like all of us here, not only are we self-motivated and hardworking, but we're only thriving in a good, supportive environment. Likewise, recurrent tumors come back in a supportive tumor environment. And in this recurrent tumor environment, osteopontin influences every cell type so they support recurrence. It can directly wake up cancer cells and help them multiply faster. It can stop immune cells from killing cancer cells, and it can increase blood vessel number to deliver more nutrients. So really, osteopontin is that alarm clock that rings and wakes up the whole tumor by getting all the cells on board for recurrence. So, can we hit snooze on this alarm clock to stop the ringing by stopping osteopontin with a drug? The answer is yes. My treatments in mice with tumors show that targeting osteopontin reduces their tumor size by 8-folds. Well, now that we know who kicked off the slumber party of cancer relapse, I believe that pairing anti-osteopontin drugs with that first round of treatment could promise not just a temporary nap, but rather a sustained hibernation in tumors. That way, once patients ring the victory bell, it is the only and the last thing that will ever ring in their fight against cancer. Thank you.
That was wonderful. Thanks very much. You?
Yeah, what an interesting talk. I think, again, I'm just always blown away by the creativity of the analogies being used and the way that really makes it clear to understand what our finalists are talking about. So thank you for all of your very varied talents. So apparently, you, beyond the lab bench, really enjoys reading and trying all the foods around the city, which in a city like Montreal, thankfully, there's no shortage of foods to try. Hopefully she's not looking at Instagram too much and actually, going and trying these real foods. But yeah, no, very interesting talk. We really love that our finalists have lots of hobbies and things that they do on their own time.
Exactly. I think I'm going to have to ask you for food recommendations after this because, again, there's like a million places to eat here, and then you check online, and yeah, it's a whole other. You could do another 3MT talk on that if you want to. More learning. Keep it going. Wonderful. Okay, we are ready to continue on with our next presenter. So, Rebecca Bellworthy is a fourth-year PhD candidate in the Department of Human Genetics. Rebecca's talk today is entitled Brain Betrayal, Immune Cells and Cerebral Malaria.
Your 3-year-old child is a whirlwind of energy, but today something is very wrong. You cannot wake her, and your only option is to walk 2 hours to the nearest hospital, where you arrive to find a young medical student is the most senior person on duty. Her inexperience makes her think your child is merely sleeping, when in fact, she is deep in a coma, the malaria parasite gripping her brain. That young medical student was me, the first of many malaria cases I saw with my own eyes. How could I accept what the nurses were telling me? There is nothing more we can do. This was just one of 700,000 malaria deaths that occur every single year. It kills the equivalent of every child under the age of 5 in the entire province of Quebec, every single year. It occurs when the malaria parasite living in the blood begins to attach to the tiny brain vessels, causing damage to the essential barrier that separates the blood from the brain. Like the breach of a dam, the parasite rapidly spills into the brain and encourages with it millions of immune cells from our own immune system. But once inside the brain, rather than attacking the parasite, the immune cells are tricked into overdrive, starting an irreversible cascade of swelling known as brain inflammation. The inflamed brain is trapped within the skull and crushed, stopping the child from breathing within 24 hours. Despite being one of the oldest diseases known to mankind, no one has ever found a specific treatment for cerebral malaria. So my research focuses on the immune cells involved in the progression of malaria from the blood to the brain. Using cutting-edge technology, we can capture each individual cell as it moves into the brain and look inside those cells to determine which ones are sending dangerous messages of inflammation. We have found 2 key drivers. They are genes expressed in our immune cells. Without them, the brain becomes completely resistant to cerebral malaria. So, do we have a cure? Well, it's complicated because these genes are very important in many immune processes. We can't live without them. So, we must find a drug which can target these drivers and switch them off in malaria, but only temporarily. Furthermore, a drug for malaria must be cheap, accessible, easy to store and administer, and extremely fast-acting. But why study malaria in a country like Canada? Well, first of all, this method of excessive inflammation is shared by many diseases, autoimmune diseases, COVID-19, even sepsis. Secondly, and more worryingly, the planet is warming, and it's leading to an expansion of malaria endemic regions. It's predicted in just a decade or 2, we might not be able to be so blind to this rapid killer.
Well, thank you, Rebecca, so much. What an impactful talk. And again, speaking of highlighting elements of presentation, I mean, I really applaud her ability to take from a story and an experience she had and then make it into research that could literally save lives. I mean, that is really bringing power to work, right? And I know as researchers, I think we all like to have purpose in our work, and so it's so clear to see that in Rebecca's work.
Definitely. A good example of me search.
Me search. More learning. New term for me again.
Yeah,
nice.
There you go.
Thank you for that.
Basically, today is a lesson for Jess, and that's why we're all here today. No, just kidding.
Thanks, everybody. Hope I get a night anyway.
Yeah.
Oh, man. Well, something interesting to share about Rebecca beyond her work is that outside of the lab, she's actually kept busy by her 2-year-old daughter, who is so far, a willing partner in her various cycling and skiing adventures. That sounds so fun. I'm sure she will continue to be a willing participant as she grows up. That's so wonderful.
Very cool. Yeah. So we are just so blown away. I think I say this every time, but it's true. Like I'm so impressed by the level of the quality of our finalists, and I think it's just so exciting to listen to what they have to share. And so that brings us to our next finalist.
Wonderful, thank you. So, Mehtab Singh is a third-year PhD student in the Plant Sciences program. Mehetab's talk today is entitled, Making Oats Punctual.
Being health conscious isn't just a trend. It's a lifestyle choice that has an optimistic effect on your well-being. And in this trend, oat is an emerging cereal for healthy lives with a Canadian consumption of 2.34 metric tons last year. From the first crunch to the last satisfying spoonful, oats offer a breakfast experience that's tasty, nourishing, and convenient, setting you up for a great day ahead. It's rich in beta-glucan and various other antioxidants which are good for your heart health and your overall well-being. However, this precious cereal is facing adaptability challenges in the changing Canadian agroclimatic conditions. Despite being a temperate cereal, harsh Canadian winters present an insurmountable problem for oat cultivation in Canada, and hence only spring oats can be cultivated. And owing to this problem, we are just left with a short span for oat cultivation because further delay in crop harvesting can lead to frost damage and crop lodging, which is not desirable. So my goal is to expedite the oats flowering and make oats punctual by not compromising with the yield, which is a really important factor, right? But we have a candidate gene in mind, VRN3, which can do this job with our collaboration with Agriculture Food Canada. This gene delays the flowering time by 5 days, which is a significant number because further delay in crop harvesting is not desirable because it's amenable to the environmental damage. So we're using a basic CRISPR-Cas9 technology, as you might be aware of. It consists of a guide RNA that acts as a torch to find the VRN3 in the whole oat's massive genome, whereas the Cas9 protein acts as a pair of scissors that cuts the target sequence that alters the gene function. I'm really proud to share I've successfully produced the first gene-edited oat lines in the world, and they're happily growing in the greenhouse at Mac campus. So in the next generation, we'll be screening those genotypes in terms of diversity in flowering time, which can be harnessed by the Canadian oat breeders to develop the oat cultivars which are adaptable to different agroclimatic conditions of Canada. And I'm doing this so that you can continue to experience the warmth of a delectable oatmeal bowl during the snowy winter mornings that satisfy your taste buds and fuels your body. And I don't see any harm to add a berry on the top. Thank you.
Thank you so much, Mehetab. That was wonderful. And in the end, when you're talking about oatmeal in the winter, that's absolutely me in Montreal. I have oatmeal almost every single day for breakfast, and it really warms me up in the cold here. So very, very suitable. And also really interesting to learn about the sustainability of oats and all that work you're doing on Mac campus again. So happy that you're here to share with us. And speaking of sharing, something else that Mehetab is interested in that is actually a bit of a business for him is product photography. In his bio, he put that he can, quote unquote, shoot up your business sales with his stunning shots. I love a self-promo, so thank you so much for sharing. Again, you got to pay for that degree somehow, so.
True that. So up next, we have Rania Gamal, who is a 6-year PhD student in electrical and computer engineering. Rania's talk today is Lighting the Way to Early Diagnosis.
2 years ago, I was in a car accident with my aunt. After they ran some tests at the hospital, we found out she has cancer. In truth, for a year prior to that accident, she'd been complaining of many strange symptoms, but was unable to get an appointment because of the strain caused by COVID. It should not take a car accident to find out you have cancer. This moved me to my current research. Imagine if we had a handheld device that could perform early detection from the comfort of your home, and not just for cancer, but for AIDS, Alzheimer's, and many other life-threatening conditions. To make this a reality, I need to overcome 2 challenges. First, I need to build a biosensor that the average person can afford to buy. This means I can only build it using mass-producible technologies. Second, I needed to perform early detection. This is the ability of a biosensor to detect the presence of a disease before it has multiplied in the body. So my challenge is to detect a very, very small amount of molecules. There's good news. We have a device that guides light in a ring-like structure that can sense down to a single molecule. Now that's about as early as you can detect anything. The bad news is that even though this device has been around for nearly 2 decades, no one has been able to mass produce it. Why is that? This is a question I've been trying to answer. In my 10 years in silicon photonics, I noticed that the way biosensors are designed does not honor the nature of early detection. The act of detecting a very small amount of molecules changes the underlying physics of the device in a way that has not been well researched. So to fix that, I built a mathematical and an experimental model of the biosensor to see what's going on when light is interacting with a very small amount of molecules. And what I found is that each molecule acts like an antenna, redirecting some of the light away and some of the light into the biosensor. This behavior can be harnessed and used to refine the design of biosensors, making them powerful for early detection. I believe other scientists could use my model to help them build biosensors that are handheld, affordable, and capable of detecting a host of conditions at their earliest stages, so that in time, it does not take a car accident or some misfortune to find out you have a life-threatening condition.
Wonderful, truly innovative work. Thank you so much, Rania.
Yeah, what an interesting talk. Apparently, Rania, when she was growing up, felt that physics was the closest thing to real-life wizardry. So here we are today doing a lot of real-life wizardry at McGill. Very cool. And on top of that, Rania has been developing and designing silicon-based devices since 2012. So this is really a lifetime passion project, and very impressive to see that kind of dedication.
Incredible. I feel lucky that we get to see a culmination of such years' work, and it does seem still like she's only getting started and continuing to have that work blossom. So we're really happy to see that as well today.
Definitely. Bringing wizardry and photonics together, that's our Rania.
That would be a good slogan, actually.
Yeah, for your
Rania,
next
you
company.
should use that, yeah. Free promo, free promo.
Yeah.
You're welcome, yeah. We got you.
The next one will be paid, though.
It's like your free trial.
Yeah.
Wonderful. All right, well, we are good to continue on.
Perfect. Donc, ensuite, on a Yuxin Zhu, qui est en première année de doctorat en génétique humaine. Aujourd'hui, elle présentera Télomère, protégez votre ADN.
Imagine, à chaque respiration, l'horloge de votre vie avance un peu plus vite et vous vieillissez prématurément. Penses-tu que je parle de la science-fiction? Mais au contraire, c'est une réalité pour des personnes atteintes des maladies télomériques. Bonjour tout le monde, dans notre sujet du jour, je vous amène dans mon projet doctoral travaillant à comprendre la région du télomère, ce qui sont des capuchons protecteurs situés aux extrémités de nos brins d'ADN. Les télomères sont comme des embouts plastiques situés au bout des lacets de nos chaussures. Ces protecteurs subtils peuvent empêcher notre ADN de se défaire. Mais si ces impôts s'usent trop rapidement, ils peuvent entraîner un vieillissement prématuré des cellules. Attends, un vieillissement qu'on parle ici, c'est pas comme d'avoir des plicas sur le visage, mais plutôt des symptômes rares et très graves comme des problèmes de peau, des ongles, des difficultés à respirer et une fatigue extrême, tout causé par des maladies télomériques. Malgré leur importance, les télomères étaient un grand défi pour des scientifiques depuis des dizaines d'années, car ils se trouvent aux très lointaines extrémités des lacets de notre ADN. Auparavant, on n'avait que de petites lampes de poche pour les examiner, ce qui ne pouvait pas éclairer jusqu'au bout de notre ADN. Mais récemment, avec de nouvelles méthodes de lecture longues, c'est comme si nous avions allumé un grand projecteur puissant, ce qui nous permet non seulement d'atteindre les extrémités de nos lacets génétiques, mais aussi d'observer nos télomères avec une précision sans précédent. Et moi, j'utilise cette technologie pour analyser les informations sur les gènes provenant de plusieurs familles afin de déchiffrer les héritages de la longueur et la structure des télomères. Je calcule et j'évalue les télomères de plus de 200 personnes et en lisant chacun de leurs brins d'ADN, mes résultats préliminaires relèvent une transmission claire de la longueur des télomères du côté maternel et paternel, ainsi que des particularités héréditaires dans la région télomérique. Mon but ultime est de décoder les télomères à travers les générations et de comprendre comment ils protègent l'ensemble de notre lacet génétique. Ma recherche a le potentiel non seulement d'éclairer les mécanismes des maladies télomériques, mais aussi de contribuer à lutter contre les symptômes liés au vieillissement. En effet, comprendre l'horloge biologique de notre vie, ce n'est plus de la science-fiction, mais la science en action. Merci.
Thank you so much, Yuxin. Another wonderful talk, and again, we're going to make the joke that I just feel like I keep learning things, but it's so true.
Yep. Life is a long learning opportunity, and Jess is grabbing it every time. So that's
little
great.
By little.
No, but thank you so much, Yuxin. That was such an interesting talk, and you're really like the code buster of DNA, so we really appreciate it. That'll really help people out in the future, and hopefully soon in this future, I will not be telling you guys jokes anymore, because I think we've all had enough of them. But one thing that's very cool about Yuxin is that French is actually her third language, so that's really impressive. Like, not only in your second language, but in your third language, to be able to communicate so effectively in front of an audience. Big ups.
Wonderful. And with that, we are ready to continue on with our third last presentation of the day. Can you believe it? That's amazing. So without further ado, let's direct our attention to Samantha Dizon, who's a first-year master's student in the entomology program. Samantha's talk today is entitled Beelining for Sustainability, a Buzzworthy Harvest.
When you think of insects, many of you probably think of creepy crawlers or annoying pests. But insects are incredibly helpful animals that just have a bad reputation. I like to think of insects as tiny employees disguised in colorful suits, and one of their most important jobs being pollination. Pollinators, like bees and flies, are like the UPS of the agricultural world, where they carry packages called pollen and deliver them to flowers to help produce fruits and vegetables. Without pollinators, you can say goodbye to your watermelons, no more apples for your pies, and importantly for Quebec, no more cranberries. Now, I know what you're thinking. Why cranberries for Quebec? Well, despite Quebec being the second largest producer of cranberries in the world, and being heavily reliant on these pollinators, there's no research on how their agricultural practices can impact these pollinator communities. Imagine, you go to work every day and your boss not knowing your working conditions? It's the same for these pollinators. That's why the aim of my research is to help fill this research gap. And with the collaboration of local cranberry farmers, I was able to collect thousands of pollinators from their fields with butterfly nets, and now I can assess two factors under a microscope: First, I'm looking at the physical traits that influences their ability to pollinate. A physical trait like body size can impact how much pollen they can carry and to what kind of flowers. For example, larger pollinators can deliver more pollen, but smaller pollinators can deliver to smaller flowers. Though they're both pollinating, they're doing so in different ways, and it's this diverse set of skills that helps maximize crop production. This is called functional diversity. The second factor I want to assess requires a species identification tool called a taxonomic key. And this tool will help me to identify what kind of pollinator species are in these farms and how many there are. In this case, the more pollinators there are, the more pollen is delivered to flowers, and the better it is for crop production. This is called taxonomic diversity. If I measure both functional and taxonomic diversity, I'm able to paint a picture of what the pollinator communities are like in these farms. And if I compare those numbers to the various cranberry agriculture practices, I'm able to see the full impact agriculture has on pollinator communities. Therefore, my research is not only economically important for Quebec, but are the first steps to implementing more sustainable agricultural practices, especially in the cranberry industry. So, let's build a future where we provide these cute little pollinators the best possible working conditions. Thank you.
That was great. Excellent job.
So popular.
Wow, thank you so much, Samantha. I have to say you just brought such great energy to that. It was so fun, and I found it really hard to say the puns in the title without laughing in front of all of you. I do love a good pun. It was certainly a buzzworthy talk. No, you don't have to laugh at that. It's okay. Wonderful. Something to share about Samantha external to her work. I mean, clearly she's passionate about science communication and also outreach, which is really cool. But outside of her life as a researcher, she spends hours baking and painting. And I don't know about you, Isabel, but I feel like those are pretty Montreal-coded activities, right? You know, cozy in the winter. What is one to do but bake? I think that's...
Bake and paint, yeah.
Yes. I might have to ask Samantha for some recipes after this again.
Amazing. And we just have an important note to share with you and remind you that voting for the People's Choice Award doesn't start until after our final presenter has presented. So please hold on to those votes, and you're only allowed one vote each, okay? So just some notes. We have our lovely rules that we need to follow, and please don't vote until after everybody's done. Thanks. And Jess, please announce the next person.
Thank you so much. All right, our second last presenter of the day. So please join me in welcoming Dominique Louer, who's a fourth-year PhD candidate in Communication Sciences and Disorders. Dominique's talk today is entitled Bilingualism's Protective Effect on Aging.
Many people fear aging, and not just because of wrinkles and gray hair. With age comes the increased risk of cognitive decline or developing a disease that affects your brain, such as Alzheimer's or Parkinson's disease. I'd like to ask you a question. How many people in this room speak more than one language? Did you know that speaking two languages could be the key to preserving cognitive health as we age? While many of us dread the thought of aging and the increased risk of disease, my research explores an unexpected solution that lies within our daily interactions: bilingualism. As the prevalence of age-related diseases continues to rise, the search for effective treatments has intensified, mostly in the field of pharmaceuticals. But what if the answer doesn't come in the form of a pill, but rather in embracing the linguistic diversity around us? Today, I'm excited to share with you how my research explores the benefits of bilingualism on cognitive health. My research dives into a concept known as cognitive reserve, which suggests that despite brain damage, we can maintain cognitive function. That means that even though our brain is experiencing damage, we can still function as though it wasn't. Previous research has shown that being bilingual actually trains your brain and helps with essential cognitive functions. This leads to the question driving my work. Can bilingualism enhance cognitive reserve in patients with Alzheimer's and Parkinson's disease? To investigate this, I use tests that measure the cognitive performance of both bilingual and monolingual patients, and I look at scans of their brain. So far, my initial findings are promising. Bilingual patients consistently outperform their monolingual counterparts, particularly excelling in the domains of language and memory. These results hint at the possible protective effects of bilingualism on the brain. Now, why does this matter? In a world where we're constantly seeking effective and accessible solutions to aging, bilingualism emerges as a powerful tool by offering a free, practical, and non-pharmacological strategy to mitigate the impact of disease. By promoting bilingualism, we not only enhance individual cognitive resilience, but we also strengthen societal resilience. Imagine a future where communities are empowered by the benefits of bilingualism, reducing the risk of neurological diseases and freeing healthcare resources for other important needs. As we move forward, let's embrace the idea that language, this beautiful human capability, can be a powerful ally in our fight against aging. Thank you.
You did it.
Wonderful, wonderful work. Thank you so much, Dominique. And sorry, I'm just smiling, seeing the relief on your face. I know we're almost there. It must feel so great finishing up these talks for all of you. So I'm happy to invite one more person that gets to do that soon next. And something that I love about Dominique's slide that I talked to her about as well in her heat is the bonjour hi. As someone who's not from Quebec, I'm originally from Ontario, I just think that bonjour hi is such a Montreal thing, and it's such a privilege to walk in somewhere and have people offer to speak to you in a couple different languages. Like, it's just so cool that we live somewhere where that's a thing, you know? But anyway, something else to share about Dominique, which again, I think shines really well through her work, is that she really likes emphasizing the importance of factors like bilingualism in maintaining cognitive health, and so also advocates for holistic aging solutions, which is really cool.
Very impressive. We do love a good bonjour hi, at McGill at least.
Yes, we love a bonjour hi.
Yeah.
Wonderful. And with that, we are ready to segue into our final presenter of the day.
Great. So last but not least, we have Maria Elisa Polsonelli, who is a first-year PhD student in bioresource engineering, and their talk today is titled No Model Left Behind, Combining Models to Predict Potato Harvests.
So I didn't draw this picture. I asked DALL-E, an AI image generator, to create a picture of a fortune teller looking at a potato in a crystal ball. And why would I want a picture of that? Well, it's because that's kind of what I do. I'm like the fortune teller looking into the crystal ball to see the future of potatoes. But the crystal ball is a computer, and I'm looking at spreadsheets of simulated potato yields. Climate change is going to have a huge impact on agriculture. Changing weather and increasing temperatures will affect crop yields. And we want to know what that might look like so we can better prepare for it and keep potatoes on our tables. Like DALL-E, I use machine learning and something called process-based crop models in order to create a picture of potato farm fields in Prince Edward Island. Now, machine learning is trained on a data set, and it learns the patterns and relationships between those data points so that when we give it new data that it's never seen before, it can recognize those relationships and predict an outcome. Process-based models, on the other hand, mathematically simulate all the processes you can think of occurring in a farm field ecosystem. And there's evidence that using both models together is even better than using either on their own. So I've collaborated with a 5th-generation farmer in order to collect actual field-scale data and model these fields at the ground level. First, we had to clean up the data that we collected and add information about the climate, soil, how the plants grow, and farm management practices, represented by that little sun and cloud, seedling, and tractor up there. Then, I ran my process-based crop models to simulate these farm field ecosystems. Finally, I took some of these simulated outputs and added them to my original machine learning model for it to learn from. And so far, our predictions have been improved by 15%. Now, that might not sound like a lot, but it means that a farmer could choose to use 10, 20, maybe even 30% less fertilizer, preventing excess from entering the environment. Or they could act preemptively to boost low yields, ensuring food security. All because they trust the models more. My research on enhancing crop yield predictions makes that crystal ball just a little bit clearer, so that when we ask questions like, will we need more irrigation with climate change? Can I use less fertilizer next year? Or maybe most importantly, will we still have enough French fries in 2050? We can feel more confident about the answers. Thank you.
You did it! That was awesome!
Wow, what a wonderful, energetic way to end our talks today. And I'm relieved to find out that we will know the fate about having French fries in 2050, because that's very near and dear to me.
Yes, don't worry about your French fries. They will be around. Apparently, also, we are now allowed to make all the puns we would ever want to make. So, Jess, go ahead. No. Okay, so what's really cool about Maria Elisa is that their passion for food, sense of adventure, and interdisciplinary background is really what brought them to both computer science and agriculture and led them to explore food systems. So basically, very, very cool stuff, and really trying to help fight against climate change through looking at how we can protect our food systems. So very, very impressive. I was supposed to actually invite our judges to go deliberate, but they've left without me, so they're way on it. They're ahead of me. I love the proactive energy here. So that's great. We are actually, as you can tell, done our presentations, and now we're just going to talk about what's coming next. As I kind of mentioned earlier, the voting for the People's Choice Award has now started, so it's open. You can vote, but you're only allowed one vote, okay? One vote. No cheating. The QR code is on the slide behind, and if you're tuning in through the live stream, there's a link in the YouTube video description which you can use to vote. Donc, c'est maintenant l'heure de voter pour le prix de public, et tu peux utiliser le lien qui est comme disponible au-dessous du vidéo YouTube. Also, an important note is that voting for the People's Choice Award will be closed at 4:40, so 4:40. The voting will be closed at that time, so no more votes will be accepted after 4:40 p.m. So just to be sure to get those votes in. And yeah, now it's up to Jess to lead us through the next steps.
Yes, thank you. So we have a wonderful opportunity here where we have these 15 distinguished presenters with us and the judges are deliberating. So now we're actually going to open up the floor for a Q&A period, which is really exciting. So I'm going to please invite all of the presenters, when you get a chance here, to come up and join us on stage. I will explain how this will work in a second, but essentially there'll be a mic we're going to move to the center, and I'll prompt on people to ask questions from the audience.
Yes.
Precisely.
Exactly.
Right.
Is the QR code working? No. Okay.
Stay tuned. All right.
We might extend the deadline for the People's Choice Award in that case.
Yes, we'll make sure to give you an update on that. And I guess we will keep it up there as that difficulty is figured out.
Okay. It should be working, so if you're having some challenges, maybe approach the slide. Yeah.
Yes. Okay, I see some.
Oh, yeah, so if you're on Wi-Fi, maybe go onto your data, because the Wi-Fi in this building is not the best. It's a beautiful building, though, and we appreciate that.
Yes, we love being in this building very much. Okay, it looks like there's some silence here. I'm going to guess it's at least working for some people. Yes. Wonderful. Thank you for that confirmation. Yes, we love a thumbs up. Thank you. As a teacher, I love a thumbs up. Thank you so much. Okay, awesome. So we have some wonderful, distinguished folks behind us. I'm going to try to move out of the way. Yeah, please move in. We want to make sure we see all of you.
Nice and squished like sardines today.
Like sardines. All right. Okay, so as you can see now, in the center aisle here, just slightly off to the side, we have a podium. And so at this moment, we'll invite any and all, because we have time to fill, so we'd love to hear from you, audience members, to ask questions. And you can ask questions to one presenter in particular, a general question, a question about themes, whatever you'd like. So I'll pause for a second and wait for hopefully a couple people to arise. You can form a line behind the mic with your questions.
3MT related, though. Thanks.
Yes, 3MT related to their work. Wonderful. Yes, please share.
Hi. A number of you gave talks related to either the tumor or disease microenvironment. Can you raise your hand? I think there's 4 of you. Yeah. I was wondering if you would all provide to me an answer on what you think is the most likely target, or what you think will be the best hope for making the microenvironment inhospitable to disease growth.
Question. Anyone want to answer first? Sure. Great.
I really like that question. And I think one thing that's really cool about the group that did that was that most of us study different forms of cancer. And so I think that I don't necessarily know if there's a right answer to that. I think a lot of it will depend actually on the type of cancer you're looking at, and then even breaking it down further into what type of microenvironment you're having, because they can have a lot of different characteristics.
Thank you so much. That was a very interesting answer. Anyone else?
So based on my research, one of the things that we're working on right now is actually to define what these targets exactly are. But one of the categories we're very interested in is there's a type of chemical signal called a growth factor. As the name would suggest, these are the factors that when they attach to a cell that has the right receptor, then tells the cell to keep growing. Or if you're a dormant cell or something like that, then that could also be one of the things that wakes you up potentially. So what we're interested in is looking at how the microenvironment talks to the problematic cells, whether it's a dormant cell, whether it's a stem-like cell, or another sort of cell, through these growth factors. At least that's what I'm interested in, and seeing all the different ways to do it. Because right now there are some drugs out there on the market that stop the most well-known pathway, but the cancers, they're very ingenious, so they find other ways to bypass those ways that we block. So I think it's you need to block multiple things and block it comprehensively. I think that's what I'm finding so far.
All right, yeah, would you like to?
Thank you for the great question. I'm a big fan of something that is not alive in the tumor, so a lot of proteins, specifically matrix proteins, like collagen, which we put on our faces so we can have bouncy skin. But when these proteins are a lot higher in tumors, they cause something called fibrosis, which extends to a lot of other diseases. So although they are not alive like immune cells or blood vessel cells, they do help prevent drug getting into the tumor, or can help cancer cells escape and disseminate to other organs. So I'm a big fan of focusing on these matrix protein and the potential that they hold in becoming a therapeutic target.
Thank you so much. Do we have any other questions from the audience? Come line up. Yeah. Great. Oh, fight for the mic.
Is it okay? So about the bilingualism, is it important that you spoke 2 languages in the past, or the current usage? I'm thinking of someone who's already a certain age and maybe diverts to just 1 language. Is it important to make that person talk again that other language that she or he talks?
Thank you for the question. This is a question that I get all the time. There's no right answer to it, but there's many different factors that can contribute to this advantage, and both of them are correct. So whether you've grown up speaking 2 languages or 3 languages, or whether you learn a language later in life, both are great for the brain. We are seeing in the literature that it's better to speak a language from early on. So people that grow up speaking 2 languages, because there's more familiarity and there's more happening throughout the life, it is the better option, but it's also just as great to learn another language later on. They're both good.
Thank you.
Thank you so much. We had another question, yes.
Hey, wonderful talk to all of you. And I have a question specifically for Ronnie. Hope I pronounce your name right. So regarding the development of a portable biosensor for the light detection, I'm wondering whether you can provide some insight or whether you have already tested the pros and cons versus between the light sensor and also the sound sensor, or whether it is possible to actually combine these two, because light actually can crosstalk well with different sound. So in terms of the wave connection, so I'm just curious whether you have explored that possibility as well.
I have not thought about combining sound with light. I mean, it could be an option, like, and not just sound. Like, you could also combine a chemical sensor or a mass-based sensor. But the main advantage of using light is an energy, right? And a lot of sensors that exist are matter, just like the molecule that you're trying to sense. So sometimes as you're performing the sensing, you end up changing the properties of the molecule that you're sensing because it's interacting with something else. So if I were to use sound, as you're saying, that's gonna change the properties. So at this point, the answer is it depends on what we find next. If we are able to sense down to a single molecule using something that is mass producible and do that reliably for a lot of different biological molecules, then there wouldn't be a need to try and enhance it. But oftentimes, when we do try and enhance it using light, one thing we do is we use like metal nanoparticles, especially gold nanoparticles, because they're very inert, they don't chemically interact. But that's an interesting thing. That's an interesting thing that you're proposing, but you don't find a lot of scientists that are doing both these things because they're such different fields.
Yeah, if I may, I also have a follow-up question on that, because previously in my master, I actually studied the protease in the tumor microenvironment. So in reality, yes, you would wish to detect one single signal, but in reality, it's more like a soup. So you always see a mixture of multiple signals. So it's important to actually mathematically model whether it's possible to deconvolve different signals. So that's the reason why I was asking, okay, when you have a mixture of signals, can you really separate them apart? But yeah, thanks.
I guess for when you're sensing with an electromagnetic field or light, you really are either measuring a frequency shift or a phase shift, or sometimes a change in decibels, like basically there's absorption, so you have less power being transmitted. So you don't really get that. I'm guessing in your case you have maybe some resonances due to different molecules and they're mixing. At the end of the day, you just want to see the total change due to the amount of molecules that you have, whether it's 1 or 3 or 100. And you want to distinguish between those two. So 2 molecules are going to have more change than 1, if that makes any sense. So we don't really care that much about separating, if that makes any sense.
Yep, thanks.
Thank you so much. Do we have any other questions from our lovely audience here today? Yes.
Great.
Okay, well, you can go and then he will be after. Perfect.
Wonderful.
My question is for Mr. Ilagan. Yeah. Your presentation made me think of a third case where somebody answered some questions honestly and not others. Would this case be able to be separated in a third category, what would you do with this case?
Hello. Okay. Basically, methods to deal with random responding might come in. We would say in our papers there are 2 traditions. So there's one side that's more on more data intensive and then does not have any assumptions at all about how items are related. And then there's on the other end of the spectrum where it's all assumptions and then you don't need to plug in any data. So what me and my supervisor were doing were like, can we get away with like requiring neither side? And so far, surprisingly, it is possible to get a lot of good properties without requiring data or strong assumptions about how these items are related. Now, of course, if you let go of a lot of those, there's some limitation about what you can do. And so far, what our algorithms can do is only distinguish between those who are fully random and those who are not fully random. So there are other models, of course, that are in the literature that try to do what you suggest about telling like which items were they random, which ones were not, which ones were good. And these so far require like very complicated models. Like an applied researcher might come to me and say like, Michael, I have this situation, what do I do? And I could say like, oh, that's easy. You can just do an mix MC on a CFA model. And like, what the hell are those? Like, so, right? It requires advanced statistical training to even like understand what to do, and that's why me and my supervisor are like the weirdos who are like trying to get away with something with nothing, basically. And so that said, that's actually next on our to-do list. We're trying to come up with an algorithm that kind of estimates like what percentage of items was this person randomly answering, and hopefully I get good answers before I graduate.
So we just want to say that it's the final chance, if you haven't voted yet, for the People's Choice Award. Act now or forever regret your lack of action.
Forever regret. Okay.
Just kidding, but it is the last chance to vote. And we'll be closing it in the next minute. So we have another question from our audience.
Yeah, thank you all for all the cool presentations. I think I have at least 15 questions, one for each one of you, but I will just ask one. It's for the very last presenter about the machine learning models. I wanted to have some more details about the second type of models. As I got it, it was modeling the environment. I was wondering how many models did you get to do that, and what was the very difference in nature between the machine learning models and those models? Is it because they model explicitly some laws of physics or something alike?
Sorry, can you clarify your question about the specifics of the second model that you're interested in?
Exactly. How are they different from the machine learning models?
Okay, so the machine learning model is really quite like statistical. So I'm specifically using a random forest, and those are binary decision trees. So it's actually going down through this tree, and at each point, it's looking at our other data features and saying, okay, what do those look like, deciding on where to go to get to the final prediction. The process-based models, and there are many, are kind of what their namesake is. They use processes. So they're really like a stack of mathematical equations that represent all aspects of things occurring in the farm field. So we'll have them for like I can't name all of them because there's a lot. These models have been worked on for decades. But they will, have an equation for the photosynthesis and for evapotranspiration and nitrogen uptake and et cetera, et cetera. So we can actually get simulations of those daily values of what's occurring in the farm field, whereas a machine learning model, for the most part, will kind of take those features and give us one final prediction, and we will have a list of features that it shows as important, but unlike the process-based models, we can't go in and say, okay, you say this is important, but like, what was the simulated value on the 3rd of July, and see that progression in the actual possibility of what's actually happening in the farm field.
Thank you so much. Do we have any other questions from our lovely audience?
Speak now or forever hold your peace.
No. Not this time.
Not this time. Wonderful, we have a question.
Yay.
Oui, une question pour Yushin Zhou. J'étais intéressé par votre présentation. Dans le cadre de vos recherches, avez-vous trouvé d'autres régions géniques autres que les TLR qui sont peut-être en train de subir des changements à cause de l'âge?
Parce que du début que je commence mon projet, le focus de mon projet, c'est le télomère. Alors, je ne sais pas trop d'autres régions qui raccourcissent à cause de l'âge, mais
C'est ça.
Merci.
Excuse-moi. Yes. Thank you so much. Any other questions? These are so interesting so far. I'm really learning even more about all of your talks. It's great. Anyone else?
All right, well, I have a question, and if, well, the presenters are answering this question, you realize that you have another question, you can feel free to approach the podium. Yes, and this is a question for all the group. I think I'm going to start maybe with you folks in the back corner. Maybe I'll start with Conanta and Dominique, if that's okay with you. But it's a general question, and I'm wondering if you have one personal takeaway or one thing that you've learned about yourself from competing in this competition.
So personally, I took part in the 3 Minute Thesis competition last year, and I kind of miserably failed during the hits. But I decided to try again and persevere and look at where it got me. So I'd say, yeah, keep trying.
We love clapping. Thank you so much. Dominique?
This is my first time in the 3 Minute Thesis competition, so I've had a lot to learn. I think the biggest takeaway for me personally is that, I mean, everyone here, we discussed how nervous we are before these presentations, but every single presenter seems so confident on the stage. I have no idea what I look like because I black out when I present, but I think that I've learned not to worry so much about how nervous I'll be once I start talking, because if you practice it enough, as soon as you say your first sentence, the rest of it just kind of flows out. Yeah, exactly, you're on autopilot. So I think that that's something I'll take with me to my next presentation. It's very useful.
Yeah, let's clap again.
Go for it.
Hello. Yeah. Even for me, like the main motive of participating in this competition was actually to present my research in a better way. And I think I've learned throughout the workshops and the heats, it's a great practice. And I'd actually encourage everyone to, participate, and you'll get to interact with so many amazing graduates doing amazing research. So yeah, it's a win-win opportunity. Thank you.
Thank you for the promo.
I agree. I'm surrounded by a lot of the same kind of scientists, entomologists. So I know insects a lot. And I'm only ever surrounded by people who love insects. So to me, I'm like, oh yeah, this is obvious. What I'm saying is so simple, but it's not. No one else knows what I'm talking about. And it's a subject that gets a lot of bad rep, insects, So how do I say my research in a way that makes people actually care about it or are interested in it? Also, I say this to myself almost every time I present, and it's the Lulu is the Salulu. As long as you believe in yourself, it'll work out in the end. And look where it got me.
So I guess I started out in this competition just to try and get some confidence in myself. I get very nervous when I'm presenting, and I feel very anxious, and the imposter syndrome is big. So I just wanted to do some of the training really to get through. And then I actually thought I was away on holiday when the final was going to be, and then I got through the heats to a big surprise. And then they announced that the date was this week, not next week, and I'm away. So yeah, here I am, and it's given me so much confidence. I'm also a big follower of Andy on LinkedIn, who does all the coaching for us. So it was a big thing to get some personal tips from Andy. And yeah, it's been a really, really great experience. I didn't think it would come this far, but yeah, it's been really great. And everybody did so good. I don't envy the judges. So yeah, really happy to have had the opportunity.
Wonderful. Thank you so much.
Thank you, Rebecca.
On another note, voting is now officially closed for the People's Choice Award. So we'll figure out soon who is the People's Choice.
who you have chosen. Sounds like an award show. Okay, another pause for audience members if you have questions. No worries, yeah, do you have another question? Absolutely. Please share, yes.
sorry, I don't remember your name. You just spoke. It was the malaria presentation. Is there, so you're looking from the side of the immune cells, how you can lower them, turn them off, etc. Is there something you can do from the other side, the permeability of the blood-brain barrier? I don't know, dietary changes, something else that can also promote the penetration of the trypanosome?
Yeah, sure. So that's obviously, there is a lot of research. It's heavily underfunded because it doesn't really affect the places that have the money to do this really important kind of research. So that's why I'm really passionate about sharing this message. Indeed, there is like certain things in the diet and deficiencies that maybe lead to an increase in malaria, but really in cerebral malaria, it's so acute. It's really, one day the kid is fine and the next day they're in a coma, and by the time they get to the hospital, particularly where I was working, it's a population of 800,000 and one doctor and, a lousy medical student in my case. And you really need something that's acting so fast, because we need to be able to get it really quickly. So anything like diet, like you say, it does have some effect on who is getting the cases, and we really don't understand why they progress or why they don't progress. It is immune driven, so that's why children tend to die more often, because they don't have that kind of immune tolerance. Like if you get a chest infection or the flu, you're probably going to be less sick than a little kid, because it does kind of build up, but the virus just mutates so quickly, so you don't really get any long-term immunity. The same in pregnant women is the other group that it really affects, because when you're pregnant, your immunity is kind of dampened a little bit to allow some kind of bit of an alien to grow inside you. So it's really a kind of niche thing, and really the thing we need is just something that can act so quick. And we do have good candidates that are both can kill the parasite and can stop that immune reaction. And we're kind of testing how late in the day can we push it, because really once that brain is broken down, once that barrier is broken, it's just a kind of exponential, and it's really trying to find something that can act very quickly.
Thank you.
Thank you.
Thank you so much.
And I have a similar question about the telomeres. Are there life habits that are better for our telomeres and life habits that are worse for our telomeres?
Yes, there are a lot of environmental factors that could causing a shortening of our telomere. For example, however, I need to mention that I'm not an environmental science, like I'm not expert on that factors, but from what I know, smoking, for sure that will cause a shortening of the telomere. But however, by saying affecting telomere, it's not only shortening the telomere. Sometimes a too long telomere could also lead to several diseases, because as we know, the telomere is protecting our cells from degrading. But when it is too long, for some cases, some factor could trigger the telomere to be too long, and our cells are overprotected. So for some cases, when there are some tumor cell and we want to kill it in order to protect our system, they cannot get killed. So in those cases, either too long or too short, that could also be causing some problem in our body.
Thank you.
No problem.
Thank you very much.
Thank you so much.
Awesome. Thank you so much, everybody. I have another question that I would love to ask. And if it's okay, I think I'm going to start with Mehtab and then maybe go to you as well, Manon, because you haven't answered a question yet, not to put you on the spot. But I am. But I was wondering if you have anything that you would like to tell or give advice to future 3MT participants, or also yourself, if you could go back in time before competing. Any advice or things you'd say?
That's an interesting question. Never thought of this before. But yeah, I remember there were a lot of my fellow students who also registered for the competition, but they didn't even come for the heats. And they just left the training in between, sort of like there's a sensation of self-doubt, or whether we'll be able to hold down our nerves when we participate, whether we'll be good enough to qualify from the heats to the finals. But if you wouldn't have just stopped in between, you could be one of those who will be answering this question today. So I think just believe in yourself and you'll definitely go through. I also remember with my experience from heats, I was like, I didn't do my best because I feel like I'm better when there's a lot of people around me. And also with the practice sessions, we were just looking at the chairs and then just trying to be, but that gives you more confidence as well, because just if you are not okay enough to present in front of a large audience, you just get to talk with Andy and then other people, like a few people inside the room, but definitely everyone has a potential to do great, and then I think all of us did really good job and were consistent enough from the heats and all the coaching session. The team, they're really good, and then they just put in confidence in you, and then you're good to go. Final. Thank you.
Great advice. Thank you.
So I think just ask some question like why, how, so what. It's very important because we know very well our research, but for everyone else it's not very common. So answer this question is very important as researcher, and maybe ask to answer this question before to build your speech is very helpful. So thank you, Andy, for the good advices.
Thank you so much. Thank you. So we have caught wind that our judges have now made their deliberations. Ooh, okay.
Deep breath.
Yeah. So exciting times. We will now ask do we ask our finalists to take their seats once again?
Yeah.
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 And we'll
Folks,
give you a
please
final round of applause before that.
Yes, big applause. Woo-hoo! All right, so we will await the return of the judges, and then we will get to the final part where we will share the results.
Yes, today. The exciting part of the final announcement. But of course, I feel like this goes without saying, you're all winners here today. But it's true, all very impressive. So sometimes these extra labels are important, but they're not really defining. So.
Absolutely. Like, just speaking to you folks, honestly, like if I was a judge, I think I would have to pick from a hat. Like I literally, like I don't have predictions, I'm not lying. So like you all did amazing work, and, you know, be proud of that, celebrate, you know. There'll be a reception after this. We'll announce the details of that in a couple minutes.
Yeah, so soon all of the stress can be dissipated and we can enjoy all the fruits of your wonderful labor. And while we wait, we can talk some more. So I think Jess also wants to thank you once again for helping her on her lifelong learning journey. Yes. I think she's
as an educator, no, I could. Oh, perfect. Yeah. Well, great. As if on cue to save you all from me talking about my learning journey. Looks like the judges are returning, so we will give them a second and then talk some more. Perfect. Welcome back. I'm sure you folks had a really hard decision. I guess I will now lead us into the final part just while our judges here get settled. So again, as I've reiterated a couple times now, can't imagine the tough decisions that the judges have had to make. And so again, we just really want to appreciate them for their time today. And then the second group of people we have to thank are the reason why we're here, which are the presenters. So you have all absolutely blown us away with your talks. Et merci à vous pour nos présentations et la qualité de vos présentations. Excellent. So please join me in giving these folks a large round of applause. Awesome. So it is at this time that I am going to invite Dr. Josephine Nabenta-Glue, the Associate Provost of Graduate Education and Dean of Graduate and Postdoctoral Studies, up to share the results with us.
As usual, this was an amazing 3MT. Thank you very much. I know how much work went into it. I mean, we've talked about it, but it's months of work and months of the hours that the team has supported you. You've all done amazingly well. I hope you're back next year helping next year's cohort, because people give to you, you give on to other people, and this is how the community benefits from this. This has changed a lot over the years. When we first started, we would have, I guess Laura's the only person with me who remembers when we first started this. We'd have 20 to 30 people coming, forward, and then they'd have a few heats, and then we'd have the finalists. So we decided to make this more into an opportunity for training, so that people would get something out of it, like no matter what, right? It's fun having the event at the very end, but it's the whole path that you took here, the whole path that everybody else took during the trainings. Thank you for your coaches. I do see Andy on LinkedIn too, so I like his stuff. I want to thank everybody at TLS, Mithura, who's put her whole passion into this and made it what it is. I'd like to thank the co-hosts, because I used to do this at the beginning and I hated it. Like you look at the judges and you go, have you done? Like, okay, 2 more sentences? So it's a very difficult job, and you've done an amazing job. Thank you.
Thank you.
So I have the list here. We're going to start with the People's Choice. Once the QR code worked, it did work at the end. So it's Shamika Shinoy. Third place, it's a prize of $300, Dominique Lumley. Ma thèse en 180 secondes, vainqueur français, Manon Fantino. Keep it going. So I skipped one. The second prize, $500, is Michael Luo.
Wow, awesome.
And the English winner is Dominique Lower.
Yes! Oh, I'm so happy for her. Yeah! Thank you. Okay.
Okay, just convince everyone to become bilingual, at least bilingual, right? If not trilingual. So thank you very much, everybody. This was tremendous. I want to thank the judges. You were gone for a while, so I know that wasn't easy. Thank you for the work. It's not easy at all. And thank you for the audience, because for all the work, it's really nice to have it, families, friends, lab mates, supervisors here, appreciating the work that went into it. We all benefit from this. And we're going to announce a reception, right?
Yes. Thank you so much. He's thinking, yes, Well, we did it. We're here.
Yeah.
We're at the end. What an exciting afternoon.
Yeah, this is the last time today that you'll hear us talking into these mics. So
Woohoo.
everybody wins.
A treat for everybody. Well, thanks again. This really has been a really joyful afternoon. And again, our presenters, literally the reasons we are here, just outstanding work. But also you, the audience members, both in person and virtually, because we know there's a lot of you there. Over 200 people tuning in today, which is such a large number. And you know, just really shows the great talent we have here at McGill. So merci à tous nos spectateurs. Thank you so much for everyone. And we invite you to please stay for our reception. There's food and refreshments in the room you entered through until 6. And last thing is just for the presenters and the judges, we just ask you to stay a moment with us here just so that we can get some photos before we move to the reception. That is all. You are dismissed.
Yes.
Thank you very much.
Thank you so much.